Hello and welcome to this BioProcess International Ask the Expert webcast. I'm your host, Alex Nicolaitis, the webcast coordinator for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the question and answer window on your screen. After the presentation, we'll begin the Q&A portion and I'll ask our speaker your questions. Your questions in the Q&A window will only be visible to myself and our speaker. So thank you for joining us today. It's now my pleasure to introduce our speaker, Eric Isberg, Vice President of Life Sciences from Civilix.
Thank you, Alex. Hello, everyone, and thank you for attending today's presentation. Our agenda will begin with an introduction to Civilix and our fluoropolymer container technology. I will then discuss the importance of container closure integrity for regenerative medicine and other live tissue applications. After this, I will describe a method for testing container closure integrity using the ASTM D4991 shipping test and the results of this method when testing Civilix containers. We will end the presentation with a short Q&A session. So let's get started. Civilix is a manufacturer of containers made from PFA, FEP, and ETFE fluoropolymers. Our manufacturing facility and clean rooms are located in Eden Prairie, Minnesota, near the city of Minneapolis. We are the only supplier of ready-to-use fluoropolymer bottles, vials, jars, and other containers. And we are the only supplier of PFA bottles for an FDA-licensed autologous tissue product. Fluoropolymers have several distinct advantages, including extremely high purity, very low extractables, thermal stability and a very wide temperature range, and unmatched durability and essentially unbreakable during use. The importance of tissue container integrity includes catalog labware can break during use and shipment. This can be catastrophic if the container is being used to transport cell or tissue products destined for the clinic. When selecting containers for critical CGT applications, I recommend only using containers that have been adequately tested to industry standards. Lab jars are designed for general lab use and not for shipping. The closures and containers are commonly made from different materials having different mechanical characteristics. Containers and closures can fail during shipment and in particular may not survive the pressure changes during air shipment, leading to container leakage. Sometimes leakage problems are not even detected until use during commercial manufacturing. Our Purelex containers have a superior closure design, ensuring a better seal and better protection of contents, including a single product contact material in both the container and the closure, high precision molded sealing surfaces, and a ferrule style seal which works even at liquid nitrogen temperatures. The ASTM D4991 is a standard test method which covers the testing of empty rigid containers under differential pressure conditions like those which can occur during air transport. It is an important test for those considering using any container for critical shipping applications, particularly when maintaining sterility is required. The test is a difficult one for off-the-shelf jars and bottles to pass. Details on the test method. The empty rigid containers are first prepared by sealing the closures using a torque setting which simulates actual usage. The containers are then immersed in an ethylene glycol water solution in a sealed transparent test chamber which is subjected to gradually increasing partial vacuum. During depressurization, The containers are observed for signs of leakage in the form of air bubbles leaking from the closure seal. Once the testing is complete, each container is also inspected for the presence of fluid in the container. Five 1-liter Purelex PFA bottles and 5 120 ml Purelex jars were tested to a partial vacuum of 28 inches of mercury for 30 minutes. The containers were then removed from the chamber, dried, and inspected for any sign of liquid leakage. All Purelex containers tested using D4991 passed the testing with no leaks observed. The ASTM D4991 test method is an important method for testing containers for critical shipping applications. Although the test is a difficult one, the Purelex bottles and jars all passed. This is due to their ferrule-style closures, durable construction, and closure torque settings validated by Container Closure Integrity Testing, or CCIT. If you're interested in more information about our complete line of Purelex fluoropolymer containers, feel free to visit us at www.civilix.com. Thank you.
Okay, great. And as a reminder to our audience, you can go ahead and type in your questions for our speaker now. So our first question is, why do off-the-shelf containers have issues passing D4991?
It's a good question. Off-the-shelf containers are really designed to be used within a laboratory setting. They're not designed for shipping, and they're not designed really for holding product in an aseptic fashion. In some cases, the closures aren't even connected to the main container using threaded seals. Sometimes it's a snap cap even. And in those cases, it's very, very difficult to maintain integrity in that seal area.
And what are the most common ways containers fail during shipping?
I think the most common way that we've seen is that the seal will actually separate. It can happen due to the difference in pressure, particularly with air shipment, where you get a lower pressure. Also during air shipment, you'll get lower temperatures. Sometimes the hold area does not have adequate temperature control, for example, and so you might get very cold temperatures. In that case, the cold temperatures cause the different materials in the container and the closure to expand and contract at different rates, which again can lead to leakage. In many cases, these inferior containers are actually required to be in an outer bag, right? And so they're sealed within like a Ziploc, for example. In a lot of cases, the end user will receive the product after a shipment and then find liquid has gone out of the container into that secondary containment bag. So they'll know right away that the container is leaked.
All right, well, it looks like we're running short on time, so if we don't get to your question, we'll be passing them along to Eric, who can follow up with you directly. Please go ahead and continue to type in any questions you have, and we'll get those passed along. The last question for the webcast is, are there other standard methods used to test containers prior to use for critical tissue applications?
Yes, there are other methods. There are other ASTM methods that focus on not only the container closure system, but also on the packaging. As well, there are container closure integrity tests that can be performed that look at the primary container itself. One example is a dye penetrant test, where the container can be exposed on the outside to some type of dye, which again, if it leaks into the container, can be readily seen upon inspection. I recommend the D4991 test personally because I think it's the most holistic test. It shows performance of the container in a real world situation. And it's quite easy to execute. So you can execute it multiple times on larger volumes of product at a time.
All right. Well, thank you so much, Eric.
You're welcome.
And thank you to our audience for joining us. The recorded version of this webcast will be available for on-demand viewing on our website. And as a registered attendee, you will receive a follow-up email providing you with a direct link. We look forward to having you join us at future BioProcess International Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.